Okay, we said we'd go over these, so we'll go over these. Number one, list them in order from least to greatest. Whoops, least to greatest. So first we need to do, we have all improper fractions, or mixed numbers. So to order them better, we can either find a common denominator or we can turn them all into decimals. We should know a few of these decimals already, like 2 1/3 is 2.33. 2 3/5. 3/5 is just 0.6, 0.60. 5/6, hopefully know, is 2.83. Repeating, the only one we shouldn't really know is 2/7. And remember, if you don't know how to find a fraction as a decimal, you can always divide it out. Top in, bottom out. 7 goes into 20 2 times. 2 times 7 is 14. We get a 6. We can add another 0 here. 7 goes into 60 8 times. So 2 2/7 is about 2.28. Okay. So which of these is the smallest? Well, that's 2 2/7 here. So which of those comes first? Either C or D. So you can cross out these two. And the next is 2.33. That's 2 1/3. That checks out on both of them. The third smallest, 2.60, which is 2 3/5, which removes answer C. So it's got to be D. Okay, next one. This one, it's a little bit difficult. Which of these equations represents the data on the graph? So what we need to do here is we need to figure out what are our points on this graph here. So we take any point on the line, preferably one that we can identify. So where the line crosses our axes here, or anywhere where it's on integer values. So like we have this one point that's at, let me make a table too. Make a better table. X and Y. We have this one point where X equals 0 and Y equals -3. Okay, then we look where else. Well, it crosses this point here where X is 2 and Y is -2. We can keep going. We see we have this point here at 4. I didn't make my line long enough. 4, -1. And if we kept going, we have this point where X is 6 and Y is 0. Alright? And from here, since the equations it gives us are kind of ugly, our best bet is to just check them. So if we check our first one here, so we have X minus 2Y equals 6. So if I substitute in a value for X and a value for Y, I should get a total of positive 6 every time. So X is 0 minus 2 times, and Y is -3. And this should equal 6. That's what we want to know. So -2 times -3 is positive 6. Remember, a negative times a negative is always positive. 0 plus 6. Does 0 plus 6 equal 6? Yes. Alright? So it works that first time. Just because it works one time doesn't mean it works every time. So we check the next one here. So if we try 2, -2. It's the same thing. X 2 minus 2 times our Y value, which is -2. And it should still equal 6. Alright? So -2 times -2 is positive 4 plus 2. Does 2 plus 4 equal 6? Yes. Yes, it does. Alright? And let's try one more. Let's try this last one. So we have 6 minus 2 times Y, which is 0. And does that equal 6? Well, -2 times 0 is just like anything times 0 is just 0. And is 6 plus 0, does that equal 6? Of course it does. So A is our correct answer. And if we were really doing our best job, we would check all these other ones and see if they don't work, but we want to go quickly, so that's the answer, say. Okay, good. Alright. Number 3, park a car in a garage that charges $8 per hour on weekends and $7.50 per hour on weekdays. What is the percent increase? Okay, so anytime we see percent, we know we can probably make a proportion out of this. Since we're talking about we want to find this increase, increase can be part of our proportion. Okay? And since we're talking about percents, we always want to have this percent down here, which is 100%. So we think, what could represent 100% in this case? Well, since we're talking about dollar amounts, we can say the original amount, what we started with, can represent our 100%. Okay? Then we just need to figure out what is our increase. So how do we get from $7.50 to $8? Well, what is the difference between $8 and $7.50? So we just subtract and we get 50 cents. So our increase is 50 cents over our original price. The original price is what we started at, which is $7.50. And we want to know what is that as a percent. Okay? So we have our proportion. We can solve this. So we can take 100 times 0.5, or we just move the decimal 2 places over, we get 50, and we divide that by 7.5. Since we don't want to divide by decimals, move our decimal over 1 place, move this decimal over 1 place as well. So really we want to know how many times does 75 go into 500. Well, looking at our answer choices, it's either going to go in 6 or 7 times. Let's see, what is 75 times 6? We get 0, 3, 450. I can't get another 75 in, so we say this is going to go into it 6 times. And then 450. We subtract here. We get 50 again, which means this is going to repeat. This is just going to keep being 6 over and over again. So it's not 7 1/8, it's not 7 1/3. Which of these percents, which one of these percents is the same as 0.6 repeating? Is it 1/4 or 2/3? Hopefully you recognize it is 2/3. Okay, there's your answer. Alright, Caroline's desktop has a length that's between 3.5 and 4 feet and a width that's between 2 feet and 2.5 feet. What is a reasonable estimate for the area of her desktop? Alright, the way I like to think of these problems is since we have lengths that are somewhere between these measurements. So we could estimate and pick a number between them, or we can do it the safe way here and consider both possibilities. So let's say she has the smallest possible desk that we can make and the biggest possible desk we can make. So the smallest desk will be 3.5 feet long and 2 feet wide. So we can put that here, 3.5 by 2. And then she has the biggest desk she can have, which is 4 feet by 2.5 feet. And then we just find what is the area of both of these. So what's 3.5 times 2? That's just 7, or 7.0. And then 4 times 2.5, well, if you don't know that, that's not as good as it could be, but whatever. This is, surprise, just 10. Okay. So her area has to be somewhere between 7 and 10. So let me just look which of our answers fall in between 7 and 10. You guessed it, it's only 8.5. And that's it. That's all there is to that. Alright, number 30. This is probably one of the more work-intensive questions on here. So an ink cartridge for a copy machine printed 423 pages. A newer cartridge could print 35% more than that. Which is the best estimate for the number of pages that can be printed using a new type? So again, we're talking about an increase. So it's just like the problem we did earlier. And we said that was increase over, that's right, original. And the reason we use original is because course, because we want this 100% down here. This one is a little bit different because we also have the percent increase this time. So we can put 35% up here. And then all we need to know is, where does this 423 go? Is that the amount it went up by, or is that the amount we started with? And you say, well, that's the amount we started with, so we put it on the bottom. Okay, X on top. So we could simplify this, or we can just multiply, because then we can divide by 100. And dividing by 100 is not so hard. So 423 times 35. So we get 15, 1, 11, 21. Bring down the 0. 3 times 3 is 9. 3 times 2 is 6. 3 times 4 is 12. Add these up. 5, 10, carry the 1, 8, 4, 1. Alright. Then we need to divide that number by 100, which really just means we need to take our decimal point and move it 2 places to the left, which means our increase is equal to 148 pages, which means this new ink thing, whatever, is going to print 148 pages more than the old one. So I want to know, what is the total number of pages that we can print. So what we need to do is we actually need to take this original amount and we need to add it to our increase here to find out the new total. So add these up, we get 1, 7, 5. So 571. Since it says estimate, we can assume we weren't going to get an exact answer anyway. So we find one that's close to 571, which is 560. Okay, 5 down. Almost halfway there. Alright, number 31. Bag with 10 marbles in it. Some are blue, rest are red. Calculates probability to pick a 2, blah. You can read that, whatever. Okay. So what makes this interesting is this is different from how we usually see it. Usually we see there's 7 red, 3 blue in the bag. What's the probability of getting 2 blues? This time it's saying, here's the probability, here's the final answer. It wants to know, how did we get that? Which really means we need to try all of these out. So it's going to be different depending on how many blue marbles there are, but we're always pulling out the same thing. We want probability of getting a blue, and then blue again, without replacing it, without replacement. So if we look at our first answer choice here, we have 3 blue marbles out of how many total? Well, all these are the same. 7 plus 3, 6 plus 4, 4 plus 6, 3 plus 7. Those all add up to 10. So our possible outcomes is 10. So to get a blue marble here is 3 out of 10. Okay. Then to get the probability of the second one being blue, we have to think, if we take 1 blue marble out, how many are left behind? Well, you take 1 away from 3, you get 2. You take 1 away from 10, you get 9. Okay. So we multiply this out, we get 6 over 90. We simplify that, we get I think we can simplify this all the way down. Actually we can. Whatever. 3 out of 45, which simplifies to 1 out of 15. So that's not it, because we want 7 out of 15. And actually, if we look at it, 115, that's nowhere even close to this. So we're gonna need a lot more blue marbles. So let's try 6. Because if we think logically, if we try 6 and it doesn't work, then if our probability is too low, the answer has to be D. If the probability is too high, then the answer has to be B. So you really only have to check one more answer. Okay? Logically speaking. So if we have 6 blue marbles, what is the probability of getting a blue the first time? Well, that would be 6 out of 10. And the second time, since we picked 1 out, that'll leave 5 blue marbles out of 9. And we can simplify this before we multiply. So 5 and 10, we can divide both of those by 5 and get 1 and 2. 6 and 9 we can both simplify by 3. So we get 2 and 3. So this one here we get 2 add a 6, which is the same as 1 add a 3. Okay, so 1/3 is our answer for that one. And then, so we compare that to 7/15ths, and you're like, oh, I don't know what that is in 15ths. So we can change this back to 15ths. If we say 3 times what is 15, that's times 5, times 5. This is actually equal to 5/15ths, which is still too small, which means our answer should be D. We can check it just to be sure, because that's what we do. So if it's 7 blue marbles, that's 7 out of 10. The second time would be 6 out of 9. We simplify what we can, and let's just simplify straight down this time. 6/9 is the same as 2/3. We multiply straight across after that, we get 14 over 30, which does indeed simplify to 7 over 15. Okay, there you go. So remember, probability, just multiplying fractions together, multiplying ratios to get your answer. Okay. Number 7. All right, this one's looks difficult. It's actually one of the simpler problems on here. So computer printer on a wooden stand shaped like a regular hexagonal prism. So remember, when we say regular, that means all the sides on our hexagon are going to be the same. And if it says the side length is 0.5, that means each side on here on our hexagon is going to be 0.5. 0.5 and a height of 3.5. Put it up here. So what is the lateral surface area of the printer stand? So lateral means I don't actually care what the area of the base is. I don't actually care what the area of the bottom is, the bottom base. All I care about is these 6 rectangles that form the sides. So our formula for that, S equals perimeter of the base times the height. So the perimeter of our base, since it's a hexagonal prism, has to be the hexagon. So the perimeter of that is just going to be 0.5 times 6, since there are 6 sides. And that gives us 3.0. You also could add all that up. You get the same thing. Okay, so 3. The height of the prism is 3.5. And then 3 times 3.5 is 10.5. And there's your whole answer. That's it. Nice and simple. Okay. 33. This one's not quite as simple, but really not that bad. Let's see. What is the surface area in square inches? So again, surface area question. This one's a little bit different. This is a triangular prism, which means the base has to be a triangle. Okay. I don't care which way it's facing. I don't care if this rectangle's on the bottom. If it says triangular prism, the base is a triangle. Okay. So our formula for this one, it doesn't say anything about being lateral, which means we're going to solve for the total surface area. So that formula is S equals BH, which is the same formula as last time, which gives us all the rectangles, but this time we need the 2 bases. So it's literally 2 times the area of the base. Okay, so we need the perimeter and we need the area of our triangle here. So we have 3, 5, 5, and 8. All right. So the perimeter of this, we just add up the sides, add up the outside, not this 3 in the middle. So 5, 5, and 8 adds up to 18. We need the area of this triangle, so we need to remember our formula for area of a triangle is half the base times the height. We also need to remember which of these is the base, which of these is the height. We need to remember that they are connected by a right angle always. So we have 1/2 the base we can call 8, the height we can call 3. Half of 8 is 4, times 3 is 12. So our area of our base is 12, perimeter of our base is 18. We can fill these numbers in. 18, area of the base, 12. The height of the prism, the distance from one base to the other, is this long side 60. And our 2, as always, is just happy to be a 2. Okay, then we just have some calculating to do. 18 times 60 works out to 1080. If you don't believe me, go try it. I dare you. 2 times 12, 24. Add them together, we get 1,104 inches squared. And there's your answer. Okay. Not so bad, just takes a little bit of work. Alright, just 3 more. We're almost there. And only one of them is tricky. I promise. Alright, Melinda built a ramp for her skateboard. Miranda's a cool kid and skateboards. Using a wooden board in the curb. Lower end of the ramp is 5 feet from the curb. So we have the distance from ramp to curb is 5 feet. And the curb is 0.5 feet high. So here is the actual curb. And it goes like that. And then her ramp, which is green, connects the two. Right? There's our picture. And here's our skateboard. Radical. Right? This is a really deep joke. Somebody will get it. Hopefully. If the top of the ramp is leaning against the top of the curb, how long is the ramp? So we want to know what is the length of this piece right here. And so we just need to see what kind of shape did we make here. Hopefully everyone's screaming at their computer. This is a right triangle. Okay. And we're solving for the side across from the right angle, so this gets to be C. We have a handy formula that'll help us find the missing sides of right triangles. It looks like a squared plus b squared. Oh, I always do that. Not plus. Equals c squared. Okay. We fill in our side lengths. Since we're solving for C, we leave that. 0.5 and 5 can be A and B, and those numbers can be swapped around however you want to do it. Oops. Keep messing up my numbers. Alright. Then we just square it. I'll start with the easy one. 5 squared is 25. If 5 squared is 25, then 0.5 also has to be 25, and then you just need to remember your decimal. So there's going to be 2 decimal places there. So it'll be 0.25 plus 25 equals C squared. We add these together. $25 plus 25 cents is literally $25.25. And since we do not care what C squared is, we only want C, we need to take the square root of both sides. Okay? That's going to leave us with C. And we don't have to work this out because if we look at our answer choices, they're all left as the square roots. Get it? Radical. So our answer is B. That's it. That's all there is to it. And we could have figured this out. We could have estimated. Excuse me. This is just going to be a little bit more than 5. This will be like 5.1-ish. Okay. Alright, 35. This one's kind of stupid, but we're going to do it anyway. This guy, guy, won a contest when he estimated the volume of a pyramid. His guess was within 10 cubic feet of the actual value. Pyramid has square base, side lengths of 4 3/4, and a height of 12 1/8. So we can draw our little pyramid here. It's a square base, so I'm going to draw a square down here, or something resembling a square. Fill in my sides. Alright, there's my pyramid. Which of the following could have been his estimate? Here's the key word we're going to work with, estimate, because these fractions are kind of bad, and I don't want to deal with that. So side lengths on the base, 4 3/4. We're going to estimate, we're going to say that's close to 5. So here's our side lengths on our base is 5. Height of 12 1/8. So I'm not going to deal with that either. We're going to round that. That would round down to 12. So our whole height here is about 12 feet. Then we look at our formula. We want volume. Volume of a pyramid looks like 1/3 of the area of the base times the height. Okay, this one's not so bad. Our base is a square. What is the area of a 5 by 5 squared? You guessed it. It is 25. The height of this we said is 12. And we just need to take 1/3 of that at some point. And at some point, I mean right now. We could take 1/3 of 25, but we'd get a decimal because 25 isn't divisible by 3. But 12 is divisible by 3. So 12 divided by 3 is just 4. And then 4 times 25 is 100. And that just happens to be one of our answer choices. So hooray. And that's it. And you could have done this with the actual numbers, and it'd be terrible, and it would take a long time, and you get like 90 point something, and it comes out to 100. So best bet, anytime it says estimate repeatedly, let's go ahead, round your numbers off. And I say look at your answer choices. Like if this was like 100.1, I might round this to 1 decimal place. If this is 100.12, you go to 2 decimal places. But since this one rounds all of our answers to the nearest whole number, why not round all of your measurements to the nearest whole number as well? Okay, save yourself some trouble. And number 36. Computer error, interest rates, blah, 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 blah. Which of these shows order from greatest to least? They'll give you a million different reasons to order stuff, and really all it comes down to is these two words. Do we want greatest to least or least to greatest? In this case, we want greatest to least. Okay. And let's start with these ones. Let's see if we can avoid having to figure out what that is, because that looks like a pain, right? Right. Actually, it's not, but whatever. So 6%, 2/25 and 0.07. If we just start turning these into, well, let's turn them into percents. Why not? We got 6%. That's cool. 2/25. 2/25. If we want to write that as percent, we think, can we write that as something over 100? Of course we can. Of course we can. How do we get from 25 to 100? We just times it by 4. So 2 times 4 gets to stop being x and gets to be 8. So we have 8, not 6 again. 8%. 8%. You can do this. Right, go me. 8%. Then we have 0.07. If we move our decimal 2 places over, we get 7%. So let's look at these three numbers. If we're looking from greatest to least, then 8% would have to come before either 6% or 7%. So we're looking for where 2/25 comes before 6% and 0.07. So let's see. 2/5 first, then 7%, then 6%. This is maybe. This has 7% first. That can't be right, because this has to be the very first number. Well, either the first or second, because who knows? Maybe this one's bigger. But that's not the case here. Same thing for number C. Sasha's texting me telling me I haven't made this video yet. It's like weird. Okay, I've lost focus. What are we looking for? Oh yeah, 8% to come first. This one has 8% at the end, so that can't be it. This one has 8% at the end too, so that can't be it. That really only leaves answer A. Okay, those of you wondering, how can we make 62 over 1,000 into a percent? It's really not that bad. Instead of multiplying, I put 1,000 again. Da-da-da. So how do we get from 1,000 to 100? Well, we just have to divide that by 10. We can just divide 6.2 by 10, and that'll give us 6.2. I think I just said 6.2 twice. Well, you see what I wrote. What I wrote is what I meant. What I said is what I thought I meant to say, but I didn't because I'm sleepy and would rather be watching basketball right now. Anyways, 62 over 1,000 is just 6.2%. So our final order should be 8% first, 7% second, 6.2% third, and 6% fourth. Is that what we have here? Yes, still correct answer. So we are finished. Everyone should have 100. Everyone should have learned something. If you didn't, watch it again. Okay? Like, comment, subscribe. Oh, we made it under 30 minutes. Good for us. Okay, good night.